Scenario: Satellite with mass ms is in a circular orbit around a planet with me. Question: You're going to derive an expression for the period it takes the satellite to make one complete revolution around the planet. The disclaimer about this question is that this deviation is never asked in terms of the free response. It will appear in terms of multiple choice. The deviation isn't ever asked. Students will sometimes be asked to analyze the final form or give the equation. So looking at this deviation should give you a better understanding of how that final form for the period is derived. So we start by setting the centripetal acceleration is equal to the force of gravity. Now you make the substitution. The centripetal force can be defined by the mass of the satellite times v squared over r, which is the centripetal acceleration for the satellite. The force of gravity is given by this. It's between two masses over r squared. That big G is the gravitational constant. I'm trying to get a v squared alone, so I'm going to be multiplying by r divided by ms to both sides to cancel it out. Now the left side should be neatly isolated with just v squared. The reason why I want v alone is because I have a deviation that gives me the period. V equals to 2 pi r over t, which is the tangential speed that a object has going around a circular orbit. This is the only way I get the period into this equation. So make that substitution in. 2 pi r over t is now squared. So that squared is now going to be distribute. 2 squared becomes 4, pi squared, r squared, and the bottom is the time squared or the period squared. Now I flip it because I want my t squared on top. So I also flip the other side. So now radius is on top of g me. Now what I do here is multiply by 4 pi squared r squared to get rid of the bottom here. So I multiply that to both sides. What gets leave me on the left hand side is just t squared. On my right hand side, the 4 is on top, pi squared is on top. There's an r and then r squared, so it becomes an r cubed. On bottom, it just becomes big G me, which is the mass of the planet. Now I'm going to take the square root. The square root here will get me square root 4 pi squared r cubed divided by big G me. Okay. You can work with this version, but this version can still be simplified. You break up the radical into two parts, the upper part and the bottom part. The 4, radical 4 breaks down to 2. The radical pi squared just becomes pi, leaving you only with a radical r cubed left. Now you can combine the radical back in here. So the period that it takes can be defined by 2 pi square root r cubed divided by gme. This is a very unique equation for the period because it's based on the radius, which is on top of the fraction, which is an r cubed term. Also, there's a 2 pi out in front. A lot of students will just memorize this deviation, but hopefully you understand how I got it by looking over at all these steps. There you go. This is the period it takes a satellite that goes around a circular orbit around a planet of me.